Okay, we're on to question 2 now. So we've got a curve has the equation y equals 2x plus 2 over x, and we need to find dy dx. We're finding the gradient function. Okay, again, just like on question 1, before you start you need to rearrange that equation so it's ready to differentiate. So if we just look at that first of all, y equals 2x plus, you've got x on the denominator there with the power 1, so you can bring that up. Keep the 2 where it is, don't get confused with the 2, it's just a 2, so leave it there and bring that up. So it's all ready now. So to differentiate, we've got dy dx equals, that's the power 1 there, so you've got 2 times 1 is 2, the x to the power 1 goes down to x power 0, it disappears, and then you've got minus 2 times minus 1, so you've got minus 2, and you're decreasing the power by 1. Okay, so you've got negative 2. At this point you might want to rearrange it a little bit so it'll be more helpful to you later on. This is correct, you have differentiated it. So we've got 2 minus, again, just like before, the 2 is on the top, leave it on the top. You've got x to the negative 2, bring that power down so you can make it positive, and you've got x squared. So they're both right, but the latter one will be easier for you to use in the second part of the question. Okay, question 2b says hence find the coordinates of the stationary points. What you need to remember is what a stationary point means, and it's when the gradient function is equal to 0. So it's either a maximum or minimum if you picture the curve. Okay, so, and you'll find the coordinates, not just an x value, so you want an x and a y value. So don't sort of leave the question half done. Okay, here we go. So from the previous question, we had dy dx is 2 minus 2 over x squared, and for stationary points it equals 0, and you can put that implies there, so that's where we're sort of headed. At this point you really just need this part of the equation, and you're going to solve for x. So what I would do is take the 2 over x squared over to one side, times both sides by x squared, so you've got 2x squared equals 2. Divide both sides by 2. Remember, always play fair, do the same to both sides, and then you're taking the square root, and do not forget to put your plus or minus. So x is plus or minus 1. Okay, so we've got our values of x. We're almost done, but we're not quite finished because it's asked for coordinates, and by finishing like that we haven't actually given the coordinates. So let's carry on. So let's start with x equals, start with a nice easy one, positive. If x equals 1, how are we going to find y? So you've got to think, right, okay, I need the graph, so we're going right back to the beginning there and using that. Let's just write it down here again. So y was 2x plus 2 over x, and we're substituted in x equals 1. So 2 times 1 is 2, plus 2 divided by 1 is also 2, so we've got 4 there. So that implies our coordinate there is when x is 1, y is 4. So we're nearly done. We've also got x as minus 1 going back to that x value, so let's pop that in. So y, remember, is 2x plus 2 over x. If we're substituting negative 1, 2 times negative 1 is negative 2, and then 2 divided by negative 1 is negative 2, so we've got minus 2 minus another 2, which is negative 4. So the coordinate we've got there is negative 1, negative 4. So your final answer, you could put that, you could, if you wanted to finish it off, just put therefore the coordinates are 1, 4, and negative 1, and negative 4, and you're done.